Okay, number 31, it has to do with the empirical rule, the 68, 95, 99.7% rule. Solar energy is considered by many to be the energy of the future. A recent survey was taken to compare the cost of solar energy to the cost of gas or electric. Results of the survey revealed that the distribution of the amount of the monthly utility bill of a 3-bedroom house using gas or electric energy had a mean of $116 and a standard deviation of 14. If the distribution is bell-shaped, what percent of homes will have a monthly utility bill more than 102? So this is what I did in here. I graphed the distribution, a bell-shaped curve, as you can see here. I put the mean right in the center right here, it's 116, and then I scaled the axes, 3 tick marks to the right of 116 and 3 tick marks to the left, and then I added 1 standard deviation to each. 116 plus 14 is 130, and then add 14, and then add 14, and then you subtract the other way. We know the empirical rule says that 68% of the data lie within 1 standard deviation of the mean. 95% of the data lie within 2 standard deviations of the mean, and 99.7% lie within 3 standard deviations of the mean. Within 1 standard deviation of the mean, it's between 102 and 130. So this area here that I'm marking right now, guys, is about 68%. So the question is, he said, what percent of homes will have a utility bill more than 102? So we want from 102 and all the way up to the end. Well, look, guys, from the mean and up, it's 50% if you go this way, because it's halfway through. So we need to know how much is it, how much it is between 102 and 116. Well, 102 to 116 is 1 standard deviation from the left, and 116 to 130 is 1 standard deviation from the right. Together they make 68, so half of this will make what? 34. And you guys know that the other one is 50%. The whole thing is half, 50%. If you add 34% plus 50%, it will give you what? About 84%. And that's the answer to 31. 32. Let's see what 32 says. The scores from a state standardized test have a mean of 80 and a standard deviation of 10. So that's the mean, 80, as you can see in the middle. Standard deviation 10, you notice that I added 3 tick marks to the right and 3 to the left, and I added 10 to the right and subtracted 10 from the left. The distribution is bell-shaped. Use the empirical rule to find the percentage of score that lie between 60 and 80. I shaded the area between 60 and 80 in red. As you can go, when you go from 80 to 60 down, you're going 2 standard deviation to the left. The rule tells us that within standard deviation, 2 standard deviation is 95%, but 2 to the left and 2 to the right. Since I'm taking half of this, so this is gonna be 95% divided by 2, which is gonna be what? 47.5%. So this is how you use the empirical rule in here. 33. Okay, in 33, a student scores 62 on geography. So geography, the students gets a 62. And 285 on math. So math, he gets 285. The geography test has a mean of 80 and standard deviation of 15. So mean is 80 and standard deviation of 15. And the math test had a mean of 300, standard deviation of 10. And standard deviation of 10. if the data for both tests are normally distributed, bell-shaped, and which test did the student score better relative to the other students in each class? So what we need to do here, we need to change the scores to z-scores. So let me do the z-scores for the geography test. The formula is the value minus the mean divided by the standard deviation. And then we're going to do the z-score for the math, which is the same formula, x minus mean divided by standard deviation. So that would be what, guys? For geography, the score is 62 minus 80 divided by 15. 62 minus 80 is negative 17 over 15. You can divide using your calculator and then you will get the answer. For the other one, for the math, 300 minus 285. Oh, sorry, it's 285. 285 minus 300. It's the value first and then the mean. Divided by 10. So that will be negative 15 over 10, which is negative 1.50. And let me divide 17 by 15 and give you the answer. Okay, the answer for negative 17 over 15 is, which is about negative 1.13. So the larger the z-score, the better the students perform relative to his class. So since negative 1.13 is bigger than negative 1.5, we can say that the students perform better on the geography. However, guys, a negative z-score is not good because it means that you are scoring below the average. But there is bad and there is worse. So negative 1.13 is bad, but negative 1.5 is worse because it's way below the mean. So your answer here, you choose the geography. Okay, that's how we do 33. 34. A study was designed to investigate the effects of two variables, a student's level of mathematics and anxiety, and two, teaching method on a student achievement in mathematics course. Students who had a low level of mathematics and anxiety were taught using the traditional expository method. These students obtained a mean score of 370 and standard deviation of 50. So the mean is 370 and standard deviation is 50. Find and interpret the z-score of a student who scored 490. So the x value is 490. Okay. The z-score will be x minus the mean divided by standard deviation, which is 490 minus 370 divided by 50, and that is equal to what, guys? 490 was, it's 120 divided by 50, and that's 2.4. How do I interpret this one? The students score 2.4 standard deviations above the mean, and this is very good. Anything that goes beyond 2 standard deviations is called it's called unusual. So the student score is unusually high comparing to the average of the class. Okay, so that's how you interpret 34. 35. 11 high school teachers were asked to give the number of students in their classes. The sample data follows. Find the 5-number summary. The 5-number summary, guys, you can use your graphing utility. He wants the minimum. He wants the maximum. He wants Q1, Q2, and then Q3. you use your calculator, you go to Stat, Edit, then you put your data into L1, then you go to Stat, Calc, Calculate, and then one variable, Statistics. And make sure to select L1 and then hit Calculate if you have a newer operating system. And you're going to see an arrow pointing down, so press the down arrow and then you're going to see all the answers that you want. The minimum is going to be, looking at this data set, guys, it's 19. Q1 is 21. Maximum value is 36. If you do Q2, since you have 11 value, the median, if you have an odd number, just add 1 to 11 is 12. The median is the 6th value. So you just count to the 6th one, and then you can read the median, which is going to be 28. And Q3 will be 31, and that's how you do 35. For 36, guys, I'm just going to show you what to do here. First of all, in order to do a box and whisker plot, this data is organized, already ranked in order, so you don't have to. You can plug it into the calculator and then do exactly as you did in 35 to get the 5-number summary, or you can do it by hand. You notice here the minimum value is 31 by looking at the set, and the maximum is 99, and then you can find Q1, Q2, Q2 and Q3. To do the box and whisker plot, first of all, you draw a number line. The smallest value is 31 and the largest is 99, so you can label the axis go from 30 to 100. You can do 30, 50, 70, 90, 110. And then you gotta put dots for the 5-number summary in there. Like the smallest value is 31, so you're just gonna put a dot there. Oops, sorry. Then you're gonna find the median. The median is gonna be 56, which is, this is 60, and so 56 is closer to 60. It would be somewhere here. I'm just gonna give you a rough sketch. I can't just do this perfectly without using a straight edge. The median will be 72, so this is close to 70 right here. And Q3 will be 83, so it's a little bit closer to 90. And let's just fix that one. And then we have 99 for the maximum. So you just connect these two here. You connect these two with the whisker, and here's the box. Bingo. That's a box and whisker plot. 37. In interpreting a box plot data set, we know that the median is to the left of the center of the box, and the right line is longer than the left line. We can conclude that what? If the median is left to the center, that means the median is, so there is more data, you know, just toward the left than the right, because we need to get to the half of it in order to get the median. And since there is a line that is longer toward the right, you can make the conclusion that the data is coded right. So that would be D. 38. Which of the following cannot be a probability? I'm looking at the first one, negative 63. That cannot be a probability because the probability is always between 0 and 1. Probability of an event, guys, is always between 0 and 1. You can never give me an answer that goes beyond 1 for a probability or below 0. It's always between 0 and 1, so your answer A is bad. It can't be a probability. 39. Let me see what 39 is. Recently, the stock market took big swings up and down. A survey of 993 adult investors asked how often they track their portfolio. The table shows the investor responses. What's the probability that an adult investor tracks his or her portfolio daily? So we need the probability of daily. By definition of the probability, guys, it's a number of favorable outcomes divided by number of possible outcomes. Since we're selecting one at random, it's going to be out of the 993. Now, in the numerator, you have to put the number of outcomes that work in your favor. In our favor daily, we have 235. So that will be 235 over 993, number 40. Use the spinner below to answer the question. Assume that it is equally probable that the pointer will land on any one of the 5 numbered spaces. If the pointer lands on a borderline, spin again. Find the probability that the arrow will land on 4 or 5. Since we have 1, 2, 3, 4, 5 pieces, each one has a 1 over 5 chance of occurring. Since we want 4 or 5, so our answer will be 1 over 5 plus 1 over 5, 2 out of 5. Okay. So for the spinner again, if I do the spinner here and there are 5 pieces and we want any 2 pieces, so it will be 2 out of 5. 41. A single die is rolled twice. When we say a single die is rolled twice, it's just like rolling two dice. The set of 36 equally likely outcomes, he lists them there. Find the probability of getting 2 numbers whose sum is greater than 10. Well, sum greater than 10. It's what's greater than 10, guys. It's sum equals 11 or 12. We can go beyond 12 because 6 plus 6 is 12. We can go. So what are the possible outcomes here? For 11, we could get 5 and 6, or what? 6 and 5. Anything else? No. What about 12? 12, the only outcome is what? 6 and 6. So how many of those? There is 3. It's a 3 out of 36. And your answer is 1 over 12. 42. The table lists the drinking habits of a group of college students. If a student is chosen at random, what's the probability of getting someone who is a non-drinker? Okay. Probability of non-drinker. Equals. It's going to be a ratio again. The bottom number is all the outcomes. All the outcomes is the total number of people, which is 387, as you can see. It's the bottom right. Now we need people, we don't care whether they are men or women. It just says someone who is a non-drinker. How many non-drinkers we have? A total of what? 322. So that will be, the answer is 322 divided by 387. You can do the math and figure out the answer. 43. it's pretty much the same table but with different numbers. List of drinking habits of a group of college students. He wants the probability of getting someone who is a man or non-drinker. This is called the addition rule. Okay, let's call this one A and let's call this one B. It's a probability of A or B. By definition, guys, probability of A plus probability of A or B is probability of A plus probability of B minus probability of A and B. Let's put the answers here. Probability of A means probability of a man. Okay, how many men do we have here? 193 out of the total, which is 408. Plus B is non-drinker. How many total non-drinker we have here? 322 over 408. Minus probability of A and B. So we want a man and non-drinker. For the man, you go to the man and you draw a horizontal line. Non-drinker, draw a vertical line from non-drinker where the horizontal and vertical meet is your number. We have 135 men who do not drink, so it's minus 135 over 408. So you just add those two numbers and then subtract, and you get your answer. That would be 0, if you do the math, it would be 0.932. Let's go to the next question. You roll 2 dice and total up the faces. What's the probability of getting a total of 8 or 2 up faces that are the same? Okay. First of all, the total number of outcomes is 36. Now we want a sum of 8. What are the outcomes that work in our favor? So let's see. 8, you could get 2 and 6. You could get 6 and 2. You could get 3 and 5. You could get 5 and what? 3. Or you could get what? 4 and 4. Now he says if you get the same faces also you would be a winner. So it could be 1, 1 is good. 2, 2 is good. 3, 3 is good. 4, 4 is good, but we already, just counted 4, 4, so we don't count it twice. 5, 5, and then what? 6, 6. Let's count them. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The answer is 10 over 36. You divide 10 by 36 and you get the answer. 45. There are 30 chocolates in a box, all identically shaped. There are 11 filled with nuts, 10 filled with caramel, and 9 are solid chocolate. You randomly select one piece, eat it, and then select a second piece. Is this an example of independence? Answer yes or no. Well, the answer is no, and let me tell you why. Because once you eat, so let's say I want to find the probability of getting caramel chocolate. It will be 10 out of 30. If you select one and eat it, if I want to find the probability, select another one and find the probability of selecting a caramel, it's not going to be out of 30, it's going to be out of 29 because you ate one. So if the probability of the second event gets affected by your action in the first event, then the events are not independent. So not independent. But if he says, here you randomly select one piece, you look at it and then put it back, replace it. Would the events be independent? Yes, in this case, because nothing has changed. You still have the 30 chocolates. 46. Two events are not mutually exclusive, because two events are mutually exclusive, they cannot happen at the same time. Independent, if the occurrence of one event and a probability does not affect the occurrence of the other event. So we just use independent here again. Uh, 47, almost there. 47, let's see what 47 is. A human gene carries a certain disease from the mother to the child with a probability rate of 60%. That is, there is 60% chance the child becomes infected with the disease. Suppose a female carrier of the gene has 4 children. Assume that the infections of the 4 children are independent of one another. What's the probability that all 4 children get the disease from their mother? Round to the nearest thousands. Okay. So we want the probability of all 4 get the disease. So first child get it, and second child, and third, and fourth. Since the events are independent, you know guys, if 2 events are independent, probability of A and B equals probability of A times probability of B. In our case, guys, we have 4 events here, so we're going to multiply 4 probability. The probability of a child gets the disease will be 0.6. And then you multiply by 0.6, and then 0.6, and then 0.6. If you do the math, guys, you're going to get the answer, I think it is for 0.13. Finally, we got one more exercise. 48. Let's see what 48 says. You toss a fair coin 5 times. What's the probability of at least one head? Okay. At least one head. It's a little bit hard to figure out, because at least one head could be 1 head, 2 heads, 3 heads, 4 heads, or 5 heads. So this is what we do. Every time you want to do a probability of at least 1, you do the complement, which is 1 minus probability of none. So this is what I'm going to do. I'm going to find the probability of no heads, and then I do 1 minus to get my answer. What's the probability of no heads? Means the probability of all tails, which is 1 minus. Probability of all tails. Each tail has a probability of 1/2 of happening, so that will be 1/2 raised to the 5th power, or 0.5 raised to the 5th power. And if you guys do the math, you're going to get, the answer is going to be, for 48, you're going to get 0.9688. I hope this helps. If you view the videos and do the study guide, you should do well on the test.